before we go to the inequality, I want to show you how to present a solution set in the number line form. Okay, so let's go back to an equation before we go to inequality. This is an equation problem, okay, in absolute sign. So let's just solve this one. You can remember that to solve this, you have to separate this into two conditions. The first one is x plus 3 equals 8, okay, and then let's solve this by using the addition property of equality. So I will subtract both sides by -3 to make x exclusive. In the end, I will have x equal 5. Now this is the first solution for your x. Now the second condition will be x plus 3 equals -8. And if I use another addition property of equality by subtracting both sides, both members, by 3, I will have the x being exclusive, which is -11. Okay, so we have two possible solutions for this equation for your x, which is in solution sets form that we have agreed before to use as equals in braces. We put inside all the solutions, which is -11 and 5. Okay, now let me show you how to present this in other form in number line. So just draw the number line first. Okay, it ends with arrow, okay, to show that it continuously show the same pattern as being displayed in the middle. So, and then we add the tick marks just as necessary as you need. Okay, for this one I just used this tick marks, and then let's just put the number to indicate the scale, to indicate the range. Yeah, I mean, as long as you show the same pattern consistently on the number line, you have no problem. Okay, do not use different scale. So for this one, I'm using odd number scale. So I'm just showing you the odd numbers here. Okay, it's not even numbers, but it doesn't necessarily the even numbers isn't there. This is not necessary. It says that the non-integers, the decimals, the square root isn't there. No, they are there, but it's around somewhere. So let me just show you the example. If I'm asking you where is 0, you can put it, you can show it there. Okay, or where is -8? Yeah, there. Okay, where is -1.5? It's on here, right? And then where is square root of 10? Square root of 10 is around here. Yeah, there. Yeah, the numbers that we have mentioned before is there, but so the tick marks and the numbers displayed doesn't indicate that it's just that numbers that exist on the number line. I want you to be sure about that. So all real numbers are all there on the number line. Okay, so now how to show the -11 and 5 as your solution? Just put the closed circle. Closed circle means a circle and you fill it with a color. You can fill it with dark colors. I prefer that. So write on the -11 tick marks and write on 5 tick marks. So this is your method how to show the solution set on number line. Now we go to inequality. What is inequality? Let's go to the definition. The definition of inequality is a relation which makes non-equal comparison between two numbers or other mathematical expressions. It consists of two expressions on one each side of an unequal sign. So you can see that it's just like equation, but you just change the equal sign into inequalities. So the signs that we are using, or the symbols, are this one. And you can see that on the left column for this not equal, we are not using this for this chapter. Okay, so I want you to focus on this 4. Okay, this is greater than, this one is greater than or equal, less than or equal. You have learned this before, so let's just go to the practical one. Examples. Okay, let's go to the examples. The first example says, let's use math talk and English talk. So this is the symbols we use for math talk. Okay, how can we say this in language? So it is 5 is less than 10. Okay, 5 is less than 10. Or you can change the perspective. The perspective is from the 10. So another approach is 10 is greater than 5. So we can use the same statement sentence in mathematics, but we can use two different approach. Okay, so now the next one, how about this one? Okay, so this one in English talk is 1,000 is greater than negative 10,000, or from the other perspective is negative 10,000 is less than 1,000. So I want you to be careful with the symbol here, okay? We have to really understand what the symbol means, so I want you to be careful. So let's go to the application. This example one, that this is the symbols, this is the statement of inequality that we have, okay? If it is not stated what is the domain, okay, based on the agreement, so we can assume that we are using real numbers domain, okay? So let's speak about real numbers now for this inequality. So how can we say it in English talk? Okay, in English talk, I want you to notice that this is the solutions for x are all real numbers that are greater than or equal to 5. Okay, I want you to pay attention. So all numbers that can replace x, which is greater than or equal to 5, it is your solution. So if I'm putting in solution sets that we are using before on equation, so this is your first solution. Of course, 5 itself is the solution since it is equal to 5. So is there any other solutions? Yes, we have. The second one, 6. Yeah, 6 is greater than 5. And then another one, 10. Yeah, 10 is greater than 5. I'm skipping 7, 8. We have many numbers. I'm just giving you sums. And then how about a million? Yeah, a million is a real number and it's greater than 5. 11 over 2. Yes, another number which is a fraction, but it is greater than 5. So don't forget that we are not just include integers. Okay, how about this one? Yeah, of course. We have a decimal. Yes, 11.33, 11.33555, 11. Can you imagine how many solutions we have to put into this solution set? Even the repeating decimals 12.343434 is a real number that greater than 5. Square root, radicals, square root of 37 is 6 point something, which is greater than 5. It is a real number. So even this one, 5.000000000 until something in some point it's 1. So it is not equal to 5, but it is very slightly greater than 5. Even that is one of the solution. So can you imagine how many solutions we have to put into this solution set, which will be a problem if we have to put all possible answer into this. Therefore, for now, the solution set for inequality, you must put it on number line. So this is the other solutions that we have. We put the solution into number line. So to show that on the number line, all real numbers that are greater than or equal to 5, let's go to this one. So I put a number line with tick marks. So this one is not mandatory that you use these numbers. So I'm just using this, okay, as long as there is 5 here. Since we're speaking about all numbers that are greater or equals to 5. Okay, so since 5 is included, so you need to put a close circle right on 5. Okay, since 5 is included. And then since we need to show that all numbers that are greater than and equal to 5 are the solution. So all of these 6, 7, 8, 9 and continuously go to the right, and then all in between, like between 6 and 7, all numbers between 6 and 7, 6.001, 6.5, 6.08, it is included. So we cannot use the closed circle. Instead, we are using arrow. Okay, so this is how you show that all the area on the right side of 5 are the numbers that are your solution. So I usually use the shade, but the shading part is not necessary, but I'm just like to show it that all numbers, not just necessary 6, 7, 8, and 9, but all numbers that it is in between 5 and 6, 6 and 7, and continuously go right 10, 1000, 1 million. It's all included on your solution set. That's how you show the solution set for the inequality. That is the first example. The second example is, let's scroll down here. How about this one? Okay, the second example, I will go here. Okay, so if it's not stated the domain, again, I will assume it is real number. Okay, this is our agreement. And in English talk, so it shows that the solutions for x are all real numbers that are less than 1. Okay, so all real numbers that are less than 1 is the solution for this inequality. So if I put it into a solution set, again we have the same dilemma as the previous one, as this one, since we need to put all the possible answers, all the possible solutions inside the solution set. So yeah, well, I begin with 0. Yeah, 0 is less than 1. Okay, but I cannot include 1 for this part because it's not stated less than and equal or equal to, only less than. So I have to emphasize this. This is a big difference with the first example. There is an equal sign here. Okay, that one line below the greater one, but this one is only less than. Okay, so since 1 is not included, I begin with 0, and then I will have another solutions, which is negative 400. Yes, negative 400 is less than 1, and it is real number. We have other candidate, half 0.5. It is less than 1, and it is real number. Negative 11.33, yeah, it's the same. It's all of these real numbers, negative square root of 37, and even this one. This is slightly less than 1, 0.9999999, and so on, but this is not equal to 1. I want you to know that this is not equal to 1, but it's just slightly less than 1. But it's still your solution. It is still. So can you imagine how many possible solutions we have to put into this solution set? So instead of using the solution set, let's use the number line also. Okay, so how about the number line? Let's go to this one. So since we are asked to put the number line which shows all possible real numbers that are less than 1, but 1 is not included. Therefore, we use open circle, not closed circle, open circle. So open circle is a circle and you don't give a fill into it. So it's just leave it blank. Okay, so now and then since 1 is not included, but any numbers that is close to 1 but lesser than 1, it is included. Therefore, we use arrow also and a line, go to the left. Since we are speaking less than, go to the left. So all real numbers that less than 1 will be included, even negative 1.5, even negative 2.3, okay, even 0.99999 slightly here, okay, 0.8, 0.75, all is included. That is how you read the number line. Okay, so see the difference with the, okay, so I put the sheets here. Okay, I'm so sorry with the previous one. I put the sheet here, and then yeah, the shading part is not mandatory. It's just showing you this area, and continuously go to the left is all the solutions you have. So let's put it in. Okay, then I put a shade here. I just want to show you that all the numbers in this shaded area is all the solutions you have. But again, the shading part is not mandatory, as long as you show the open circle and where's the area that been covered by the arrow. Don't forget, closed circle and open circle makes a big difference. So you have to be careful in putting either it is closed or open. And then let's go to the original question. So yeah, the number line, I will play with the domain now. Okay, so how if I use the previous problem, okay, but the domain I set into integers, not real numbers. So your solution must comes from integer sets of number. Okay, in English talk, in this inequality statement says the solutions for x are all integers that are greater than or equal to 5. All integers. Okay, so if I put it into solution set, the first solution will be 5 itself because it is equal to 5. Okay, if I move further, the second solution will be 6. Okay, so since we are talking about only integers, so I will just use 6 and then 7, 8, 9 continuously, 10, and then can you imagine 1 million and so on, goes continuously to the right side if you're speaking in a number line term. So instead of using the solution set, let me use the number line. Okay, I will use this range and then the tick marks also this. So it's not mandatory this way. So you will get the idea how do you present the tick marks and the numbers. As long as the border is included and some numbers that represents the pattern is included. So first, since we are talking about x, all solutions that are greater than and equals to 5, 5 and all integers, 5 is included. So first, use this closed circle into 5. Okay, the next solution is 6 because we are speaking integers, not between. So all numbers between 5 and 6, 5.5, 5.6, it's not included. That's why we cannot use the arrow. Okay, we just use the closed circle right on 6. Okay, do we have other solutions? Yes, we have. 7, so put another closed circle. 8, yes. 9, yes. Continuously goes right. So instead of using a closed circle continuously until unlimited positive, infinite positive, so let's just thicken the arrowheads to the right. See? So it will be a big difference between the left edge and the right edge. Okay, again, the symbols, all symbols matters. Why it's thickened? Because it's showing the patterns continuously go right. Okay, 9, 10, 11, 12. That is how you show it on the number line, the inequality, for example, 3. So this is the number line. Example how the domain plays out is this one. Okay, let's talk about this statement of inequality, but the domain is even numbers. Okay, how we put it on English talk, so it is like the solutions for x are all even numbers that are less than 3. So what are all even numbers that are less than 3? So you can start to put it together on your solution set, inside your solution sets. So the closest one to 3, which is less than 3, or even number, is 2. Okay, 2, it begins with 2. So 2, and then another even numbers that are less than 3 is 0. Okay, and then you can continue to the negative sides, -2, -4, -6, -10. I'm just skipping, so because I don't want to state all of it. -1 million. Can you imagine how many solutions we have for this? So let me just stop there. Okay, I just don't want to use the solution set. Instead, I used the number line. So how to use the number line to show this inequality? Okay, remember this inequality. So I will switch into this. So how do I show the solution sets that are all even numbers less than 3? So I will put the first closed circle to the closest even number to 3, which is 2. Okay, since this is my first solution. And then the second solution is 0, right? Less than 3, even numbers, -2, -4, and continuously go to the left into infinite negative, right? For even numbers. So I will thicken the arrowhead. So see the difference on the left edge, we have a thickened arrowhead compared to the right edge. Okay, so this shows all even numbers that are less than 3. Mister, how about the tree itself? I thought that the equation, the inequality is x less than 3. Why it's not shown on the number line? So I want to be clear. The number line presents the solution sets, not necessarily present the inequality. Okay, so you don't have to force yourself to show the 3 as the border. No. For what? Because as long as you present all solution sets for your inequality on your number line, that's enough. Okay, so you don't have to put a close on open circle or anything to show that 3 is the border. No, since I have already satisfied with this information that all solutions are all even numbers, goes to the left since it is less than 3. So it is 2, 0, -2, -4, so -6, -8, and continuously get there. Okay, that answers the solutions. So I want you to be clear about this. Do not be confused with this, since again the number line shows the solution sets. Okay, doesn't necessarily have to really shows the inequality. So I hope it's clear.